Okay. The paper that I read was called The In Situ Treatment of TCE and PFAS in Groundwater Within a Silty Sand Aquifer, written by Rick McGregor, published in 2021. The paper first focused on a site where there was a contamination of TCE and PFAS in their groundwater. And obviously, this is a problem, contaminating lots of water sites, sending a lot of people looking for other sources. So in order to treat this, they went about it through injection and pumping wells. Uh, they first started by looking at the stratigraphy and lithology, and looking through the soils and trying to best interpret what the best strategy was. And that's how they landed on injection and pumping. And they saw an opportunity to try and um, take that up. And so then let's go to my figure. My figure is figure 7. And here we're looking at three of the different wells that were most important for the site and for the pumping and injection. Here we have time as the x-axis, and then on the y-axis, we have the concentration of each of these contaminants. We have TCE, which is the main contaminant that they were focused on. And then we have DCE, vinyl chloride, and ethene. The TCE was also not just looked at through the eyes of pumping and injection. They also heavily relied on the adsorption and biodegradation of it, and looking also at the chemical reduction. They focused heavily on this pumping and injection process, though, for a quicker result because biodegradation takes such a long time. So, looking at this, you see the dashed line throughout the three different graphs of the different wells, and that is where they started the injection events. And beyond that point, you can see there's a large dip for TCE in each three well locations. And then looking at DCE and vinyl chloride, they have a more gradual downslope and eventually reaching the bottom as well as where TCE ends up. The main goal of this was to see that there is a difference, that their research is helping, and that the injection and pumping wells are beneficial for this site and for the specific stratigraphy and soil that they have here. And that there could be variance within the different soils, but for their soil that they were looking at, it was very beneficial. And I think that the author chose that to prove their point that this is something worth trying for other locations. Um, and then the most important element of this to note in each graph is the ethene. The ethene seems to be pretty stable throughout and has a constant concentration. Um, this is helpful for us to have a baseline, gives us a sense of normalcy, kind of. And yet at the same time, it could also raise attention as to something they're doing could be focusing more so on the TCE, DCE, and vinyl chloride. Maybe some of uh, the material that they're pumping into these is better for those. And I think that's one of the points that they also wanted to make. And I think that's probably why it's most interesting, because we have such a stable amount of ethene while the TCE, DCE, and vinyl chloride all decrease at such a great level, going below the levels of monitoring. And it obviously made a difference for this site in particular.